Myself Dhavam from Theivanai Ammal College for Women, Autonomous. I am working as an assistant professor in Computer Science Department. Today we will discuss about some data structures in R. This R language can be first developed in 1993, Rose Hihaka and Robert Gentleman. This language can be mainly used for statistical calculation, data analysis. That analyzed data can be represented in the graphical representations. This R programming language can be mainly used for statistical analysis as well as graphical representations of the analyzed data. Now we will discuss about some important data structures in R programming language. So first data structure is vector, second data structure list, third one data frame, fourth one array, fifth one matrix. First data structure is vector. This vector data structure can be used to store they can store number of elements in a single dimensions. The stored element can be in the form of homogeneous data. Homogeneous means all the stored elements data in the form of same data types. Okay, they cannot store different data type elements. They can store only homogeneous elements. Homogeneous means same data type elements can be stored in a vector format. The general syntax for defining the vector means they can use C functions to define one vector. Within the function, you have to represent the number of elements. Data can be represented here. The elements, element 1, element 2, needed elements can be represented within open and closing brackets. All the represented elements can be stored in vector name. Okay. Here, example, the C represent the vector elements, vector data structure. Here we are storing 5 elements, that is 10, 20, 30, 40, 50 is an elements. All these elements can be stored as a vector data structure. This here V is a vector name. Using the print command, the vector element can be printed like this. The output is 10. They can display the output like this: 10, 20, 30, 40 and 50. Some of the vector operations are vector operations. Suppose you have to define one numeric vector means you have to include the elements in the form of numbers only, because vector is they can store only homogeneous data elements. They cannot store different data types. Okay, numeric vector means you have to represent all the elements in the numeric type. Character vector means you have to represent all the elements in the form of strings. Logical vector means you have to represent all the elements in the form of Boolean types, that is true or false types. Okay. Next we will discuss about vector operation. Here two vectors are taken. A is in one vector, B is in second vector. A vector they can have three elements, that is 1, 2 and 3. B is in second vector, they can have the number of elements 4, 5 and 6. Suppose you want to add these two vector means A plus B represents the vector A can be added with vector B. The output for the vector operations A plus B is they can add first element in the A vector can be added with first element in the B vector. That is 1 plus 4 is added. Finally, they can give a result as 5. So after that, second element in the A vector can be added with second element in the B vector. That is 2 plus 5 can be added and then they will give a result as 7. So and then 3 plus 6 can be added. They will give a result as 9. Okay. So next, suppose you want to add one more elements from the vectors means you have to use the append functions. The append function can be used to add more number of elements from the already given vectors. Okay. Here we will take numbers as a vector variable name. Within the number vector numbers, they can have three elements, that is 1, 2 and 3. Suppose you want to add 4 and 5 within 1, 2 and 3 means you have to use the append function. You have to use the append function. The general syntax for adding using the append function is, within the append function, first parameter is vector variable name. Second parameter is the appended value can be represented in the form of vectors. Okay. So already number is in one vector variable. They can have 1, 2, 3. That value can be added with 4 and 5. The appended value can be printed using the print function like this. The output will be given as 1, 2, 3, 4 and 5. Okay. So suppose you want to adding an element at a particular position means you have to represent the index position. You have to represent the index positions using the append functions. Okay. So in this append function, first parameter represents the vector variable name. Second parameter represents the 10, 20 can be added with 1, 2, 3 at the index position after 1. Here 1 represents the after first element 10, 20 can be added, and the final results can be printed using the print functions. Okay. So next, deleting vector elements. Suppose you want to delete one element from the vector means you have to specify the index position for the particular element. In this vector, my vector, they can have number of elements, 6 elements, they can have 10, 20, 30, 40, 50 and 60. Suppose you want to remove the element 30 means the 30 can be positioned in third position. Remove the element at a third position element means you have to give the command like my vector of -3. Here -3 represents the third position element can be removed. After removing that, vector values can be stored in the variable name my vector. Okay. So and then you have to display the vectored values using the print command. They can display 10, 20. You are giving -3. -3 means it represents third position element value, so that 30 can be removed. After removing the 30, they can display the remaining values 40, 50 and then 60. Okay. Okay. Suppose you want to remove with some condition means you have to give the condition whatever it may be. Here I will give remove all elements greater than 30. Greater than 30 means greater than 30. In this my example, my vector, they can have 6 elements. Greater than 30 elements are 40, 50 and 60. You have to give the conditions like this. My vector is greater than 30 means they can remove the 40, 50 and then 60. Here they can give and not my vector is greater than 30 means they can display like this. Okay. Okay. So suppose you want to find out the vector length. Vector length means you want to determine the number of elements in the particular vector means you have to use the length function. So that length function can be used to retrieve the length of a vectors, number of elements in the particular vector. Here x is one vector. They can have 5 elements, 1, 2, 3, 4, 5. So suppose you are giving the command like length of x means x is in one vector, they can have 5 elements, they will give the output like this, 5. Okay. You will take another vector, y is in another vector, they can have 3 elements, the length of y means they will give output as 3. Here they can have another vector name is z, length of z means 4 elements. True, false, they can have 4 elements. So length function can be used to find the length of a given vectors. Number of elements can be displaced using the length functions. So second data structure is list data structure. In the previous, in vector, they can store all elements in the homogeneous elements can be stored. In second data structure is list data structure. List data structure also they can store like a single dimensions. But in list they can have a number of elements in heterogeneous types. Heterogeneous means they can store different data elements can be stored. Different categories, that is different data type elements can be represented in list data structures. The general syntax for list is list functions can be used to represent a list data structure. Here element 1, element 2, element 3, all those elements can be represented within open and closing square brackets. Okay, this list can be assigned to the variable name. Here the example is, here list represent the list data structure. Within a list they can have here 4 different data type elements. Here 10 is a numeric type, or programming is in string type, true is in boolean type, 2.5 is in real type. Okay, so list data structure can be used to contain, they can have here heterogeneous elements. Heterogeneous means different data type elements can be grouped together. Okay, so all the elements can be contained within the list. This list can be stored in the variable name mylist. Okay, this list element can be printed using the function print functions. Print of mylist means they can display the list of elements. Okay, that is they can display 10 or programming true and then 2.5. Okay, some list operations are accessing element by index. Suppose you want to access the one particular element values, means you have to represent that element in index position. Suppose you want to retrieve the R programming, second index. R programming means I have to give that index value. Here R programming is placed in second position. I have to represent the index value. Okay, here 2 is an index value for the list. So print of my list of 2 means here they can access the second element in the my list. Here second element is R programming. They will give output as R programming. Okay, so next operations are modify an element. Suppose you want to modify, you want to update, you want to modify one element, means you have to give that index position. Suppose you have to replace the 10 with 99, means you have to assign the 99 value with that corresponding index values. 10 is placed in the first location, so that index value for the 10 is 1. Okay, I have to give the command like my list of 1. Here 1 represents the first element, that is 10. Here 10 can be replaced by 99. Okay, the output is like this. 99, they can display the output like 99 R programming true and then 2.5. So 10 can be replaced by 99. Okay, so next, add elements to the list. Adding elements to the list means, suppose you want to add one more element to the list, means how to assign. In this list they can have 4 elements they can have. You want to add 5th element, means that 5th element can be assigned with 5th position. Okay, so print of my list means they can display 99 R programming to 2.5 new items. The last newly added element can be displayed in the 5th location, that is new item. Okay, suppose you want to remove one particular element from the list, means have to set that index value with null. Okay, here suppose you want to remove third position, third element is true. You want to remove this true, means my list of 3 equal to null. Here null represents the removing the particular indexed value. Okay, they can remove the third element. The print of my list means after removing true third element, they can display the output like this. 99 R programming, third element true can be removed. After that they can display 2.5 new item. Okay, so next data structure is data frame. Okay, data frame can be used in R programming. In R programming, data can be represented in tabular format. Okay, suppose you want to represent the data in the tabular format, means you have to use the data frame data structure. Okay, so in this data frame, all the elements can be represented in vector format. Here the data dot frame functions can be used to represent data in a tabular format. The general syntax is for data frame is, here first vector is v1 equal to c of element 1 element 2, second vector is c of element 1 element 2. Okay, so df equal to data frame variable name. Here we use data dot frame functions, data dot frame of v1 comma v2. Here v1 and v2 is an vectored element. Okay, now see the example. The first vector is an student number. Here student number can be represented in vector format. 101, 102, 103 is a student number. S name can be, a student name can be represented again in vector format. Abhi, Priya, Ramya, all those names can be represented in vector format. Student percentage 98, 89, 90. So here we will take S number is in one vector, S name is in another vector, second vector, S percentage is in third vector. So all those data can be represented like this, tabular format, using the data dot frame function. A data dot frame of, here you have to represent the first vector name is S number, second vector name is S name, third vector name is S percentage. Okay, so after that this data frame can be stored in variable name df. After that you have to give the print command, print of df. Okay, so first all those elements can be represented, displayed in the column is. So first vector student number can be a student number, and the student number values are elements are 101, 102, 103. All those vector elements can be represented in column wise. Okay, so data frame can be used to represent the data in a tabular format. Okay, suppose you want to create one data frame, means data dot frame functions can be used. Here we will take the example as training. So in the training vector they will take as strength, stamina and others. Pulses are 100, 150 and 120. Durations are 60, 30, 40. Here training is in one vector, pulse is in a second vector, duration is a third vector. All those vectors can be represented in data frame format. Okay, so your print of data frame means they can display the all the data in the tabular format. Okay, suppose you have to add one more row in your data frame, means you have to use or bind method, or bind functions. Here R represent the row binding. You want to add one more row in the data frame in the table, means you have to use the function or bind functions. Here R represents row. Okay, data dot frame can be used to represent the elements in the form of data frame. Okay, so first vector is strength, training, second vector is pulse, third vector is durations. Okay, so all those vectors can be represented in the form of data dot frame. So initially we will take three vectors can be assigned. Suppose you want to add one more row, means so you have to use the or bind function. Here or bind of, so within the or bind function they can have two parameters. So first parameter is data frame name, second parameter is newly added row can be taken in vectored format. Okay, strength 110 and then 110. Okay, so after that you have to print the command. They will display the first initial first data frame. They can have three rows only. So after that newly added row can be displayed like this, strength 110, 110. Okay, okay, adding suppose you want to add one more row in the data frame, means you have to use the or bind functions. Okay, suppose you want to add one more column in the data frame, means you have to use the cbind function. Cbind means column binding. You want to add one more column in the data frame, means you have to use the cbind functions. Already in the data frame they have a three vectors, that is training, pulses, durations. So one more cbind functions can be used to add one more new column in the data frame. So in the cbind function they can have two parameters. The first argument is data frame, second is steps of C of 1000, 6000, 2000. These values can be added in the column wise. Okay, so cbind functions can be used to add one more column in the data frames. Okay, so next, fourth data structure is array. So array is an n-dimensional data. N dimensions, it may be in the form of 1-dimensional, 2-dimensional, 3-dimensional. Depending upon your needs, array can be represented. Okay, here array functions can be used to create an array data structures. Okay, so the general syntax for declaring the array data structure is: array is a function. First argument is vector. You have to represent the vector name, and then you have to represent the dimensions. The dimensions can be represented in vectored format. Here in this vector, here R represents the row, C represents the column, N represents the number of arrays. Suppose N value is 1 means they will give only one array. N is equal to 2 means a 2-dimensional array. Number of array is 2. Number of array is 2. R represents row, C represents column, N represents the number of arrays. Okay? Okay. Now we will see the example array of. So first here vector is an vector element, that is 10, 20, 30, 40, 50, 60. Totally we will take 6 elements. So here C of 2 represents the row, 3 represents the column, here N represents 1. Here these elements are represented in the form of 2 rows, 3 columns and number of array is 1. The output like this. 2 rows means 2 rows, that is 10, 20, 30, 40, second column, 50, 60, third column. Okay, and last one represents the number of arrays. Okay. Okay, so array operations are, first you have to create the arrays. So using the array functions. Here 1:8 means they will take the colon. Here colon operator represents the range of values from starting from the 1 to ending with 8. Okay, they will take 1, 2, 3 up to 8 elements. Okay, here dimensions C of 2 represents row. Here next 2 represents the column. So last 2 represents the number of array as 2 arrays. Okay, here last 2 represents number of array as 2. The original arrays are, okay, so we want to access the elements print of original arrays are 1, 2, 3, 4. Second array is 5, 6, 7, 8. Okay, this is first array, this is second array. Okay, so suppose you want to access the particular element in the array means how to give that command like array of 1 first row, second column, first element. Okay, so 1, 2, 1. So first row, second column. Okay, first row, second column in the first array. This 1 represents the first row, this 2 represents the column, that is second column. In the here 1 represents the first array. Okay, the first row, second column in the first array is 3. They will give an output like this 3. Okay. Okay. Suppose you want to modify an array values, means how to give the modifying elements, that is my array of 2, 1, 2. That is second row, first column in the second array. Second row, first column in the second array. Second row, this is first array, this is second array. In second array, you have to modify the element second row, first column. Okay, second row, this is first row and this is second row. Second row means this represents a second row in first column. First column means this is first column. You have to modify the element as 99. Okay, they can display the result as 9. This like this. Okay, after modifying 2, 1, 2, they will display like this. Okay, suppose you want to add some value in the array operation means you have to give the command. Your array name plus 10. They can add all elements with the 10 values. Okay. So 1 plus 10 is 11. 2 plus 10 is 12. 3 plus 10 is 13. 4 plus 10 is 14. Like this, first array as well as second array, they can add and then display all elements like this. Okay. Okay. So next data structure is matrix data structures. So in matrix, all the elements can be represented in rows and columns. Here row represents the horizontal, column means vertical representations. Okay. In default, all elements can be represented in column wise. Suppose you want to represent all the elements in row wise means you have to give the command like by row equal to true. Okay. Here matrix functions can be used to all the elements in the form of matrix. Okay. Here first argument represents the vector element. Second one, here this n row represents the number of rows, n column represents the number of columns. This one is an optional. Suppose you are not given by row equal to true means they will take all the elements in the form of column wise. Okay. Suppose you want to represent all the elements in row wise means you have to give the command like by row equal to true. Okay. Okay. For example, matrix functions can be used to represent the elements in the form of matrix 10, 20, 30, 40, 50 and 60s. This is what vector element. Here n row equal to 3 means all the elements can be represented in 3 rows and then column is 2 columns. Okay. In this example, they cannot give the by row equal to true command. So, all the values can be represented as default. Default means they can display all elements in column wise. Column means first 3 rows they will give command as 3 rows. 3 rows means 10, 20, 30 first column, 40, 50, 60 second column. Okay. Okay. Matrix creating and accessing operations in the matrix. So suppose you want to create one matrix means matrix 1:6 means the range of value can be taken as 1 starting with 1 and ending with 6, that is 1, 2, 3, 4, 5 and 6. Okay. Number of rows is 2, number of column is 3. Okay. Okay. Suppose you want to print matrix means you have to give the print command. Okay. The original matrix are 2 rows means all the elements in 2 rows, that is 1, 2, 3, 4, 5, 6, because number of column is considered as 3. First column, second column, third column. Rows are 2. This is first row and this is second row. Okay. Okay. Suppose you want to access the particular element in the matrix means how to give the command like my matrix of 1, 2. That is element at row 1 and column 2. First row, second column. This is first row and this is second column. The first row and second column they will match as 3. They will give the output like this, output as 3. Okay. 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 So next, suppose you want to modify a particular element in the matrix means you have to give the particular index positions. That is my matrix of 2, 3. Here 2 represents row, 3 represents columns. For 2, second row, third column. This is first row and this is second row. Second row means you have to take this row. Third column. This is first column, second column and this is third column. So second row and third column means the location is this location. So you want to modify with the value 99 means they can display the result like this. Okay. So matrix after modifying 2, 3 they can display like this. Okay. Okay. Suppose you want to add one matrix with another matrix means the second matrix is taken as 10:15. 10:15 means they will take the element as 10, 11, 12, 13, 14, 15. Okay. So second matrix are represented as 2 rows and 3 columns. So suppose you want to add first matrix with the second matrix means the first matrix, my matrix plus second matrix. You have to give the first matrix variable name plus second matrix variable name. After adding, the final results can be stored in the variable in result add. Okay, so after that you have to display the values using print command. Okay. Added values can be displayed like this. After adding first and second matrix, they will display the result like this.